Yeah, hi everyone. Good evening. Am I audible to all of you? Okay, I think I'm audible, guys. So welcome back with our LangChain series. So today is day 8 actually. So today we'll be deep diving into the LangChain expression language. That means in my previous session, I was talking about this LangChain expression language, right? I was showing you the simple, let's say, implementation of this LCL. Now in this session, we'll just try to deep dive in. Like we'll be learning different kinds of built-in, let's say, runnables. Okay, today. So these built-in runnables will help you a lot whenever you will be using this LCL in your implementation. Because going forward, whatever implementation you will see, okay, so we'll be using these are the runnables only. Okay, so please try to subscribe to my channel and hit the bell icon so that you can get the notification if I'm scheduling any kinds of session. Apart from that, if you are joining new to my channel, so guys, this is the playlist actually we created called live series of latest LangChain and LLMOps. So here we have completed till day 7. So please try to complete this day 7, then you can start with today's session. Okay, fine. So now let me write down the agenda. So whatever things actually we're gonna cover today. So let me write it here. Hmm. So today we'll be talking about built-in. Okay, built-in runnables. Okay, built-in runnables. So inside built-in runnables, you are having some runnables. Let me just write one by one. So first of all, you are having something called runnable pass-through. Okay, runnable pass-through. Then you are having a runnable lambda. Runnable lambda. Then you are having runnable parallel. Okay, parallel. So inside runnable parallel, you are having one very important thing called item item getter. Okay, yes. So these are the very frequent used runnable. Okay, inside LCEL. That means LangChain expression language. So if you see any kinds of implementations, so people are using these are the runnables. Okay. So here I'll show you each of example of the runnables. The runnables actually I have listed down here. Okay, first of all we'll try to understand the runnable pass through, runnable lambda, then runnable parallel. Okay, everything we'll try to explore. Now I think you remember, guys, in my previous session I was talking about the runnables. So what exactly the runnables? I think you remember, guys. Remember what exactly the runnables? Let's say I think you remember we created a chain. So here maybe I can show you the code example. That would be fine. So this is my LCL notebook. So here you can see I created a chain. And to create a chain, guys, what I did, I used some of the runnables. Okay, runnables is nothing but it's a executable. Okay, that means it's a sequence of executable. That means you are performing sequence of action here. So prompt is one of the action, chat model is one of the action, and output parser is one of the action. That means first of all, prompt will be creating this prompt will pass to the chat model. That means whatever output you will be getting from the prompt, that would be an input to the chat model. Then chat model will return the output. It will be taking this str output parser and it will give you the output. Okay, that means this is my runnables. Okay, these are my runnables. Got it? Yeah, these are my executable, and with the help of this runnable, with the help of this pipe symbol, what we are getting, we're getting the chain. Okay, it's the step of execution. Now inside LangChain, inside second generation of LangChain, they created some actually built-in runnables. Okay, these built-in runnables will help you to build this chain in a more, let's say, advanced way, in a more, let's say, powerful way. Now let me tell you how we can use them all one by one. So let me create a notebook here first of all. So I'm going to name it as 07 LCEL. Okay, LCL built-in runnables. So let me select my kernel. So the first thing, I'll be loading my OpenAI API key. You can also load your Grok model. It's completely fine. Then we'll be initializing our LLM. So here we'll be using chat model. That means GPT 3.5 turbo model we'll be using. Okay. So the first thing I'll be discussing about runnable pass-through. Okay, runnable pass-through. I think you remember I have written here runnable pass-through, and this is a built-in runnable. Okay, now let's try to understand what is runnable pass-through. See, it does not do anything to the input data. Let's see it in a very simple example. A chain with a just runnable pass-through will output the original input without any modification. So let me show you one example. Let's say this is the example of runnable pass-through. So it is available inside LangChain code. Okay, you can see it is having one function called runnables. Inside that, we are having different kinds of runnables, like runnable pass-through is there, then runnable lambda is there, runnable parallel is there. Okay, different runnables are available. That's why we call it as a built-in runnable. Okay, built-in runnables, because it is already built in inside LangChain. Now here we are creating an object of the runnables. Okay, and we are naming this object as chain. So let's say I'm creating a simple chain. This chain only perform runnable pass-through operation. Okay, why runnable pass-through operation? Because I want to show you the runnable pass-through example, like what it will do exactly. So here I've already written it does not do anything to the input data. That means whatever input you will be giving, the same input it will give you as an output without doing any kinds of modification. Okay, let me show you one example. So I think you remember we can execute the invoke method on top of any kinds of runnable, any kinds of executable, yes or no. So we can do it. Let's say here I will call chain.invoke. Okay, chain.invoke. Inside that, let's say I will give my name, Bappy. Okay, let's say here I've given my name. Now see, if I execute this line, so what will happen? It will give me Bappy as an output. Okay, why? Because here I told you it does not do anything, okay, to the input data. That means whatever input data you will be giving, it will return as an output. That's it. So this is the example of runnable pass-through. That means it will only pass through your input. Okay, pass through your input and it will give you the same output. Got it? Now you can ask me, what is the use of this runnable pass-through then? There is definitely there is a use of, because whenever you will be creating the chain, so the first thing what user will do, guys. So let's say whenever I'm creating any kinds of, let's say a LangChain project, or let's say LLM powered project. So the first thing, user will give the input, right? Okay, user will give the input, and this particular input I have to take as it is. So whatever format they are giving, I have to take as it is. Okay, so we'll be handling with the help of runnable. Okay, runnable pass-through. Okay, so that is the idea. That means whatever input data user is providing, you will be handling through this runnable pass-through. This is the idea. Got it? Now, second, let's try to understand the runnable lambda. Then we'll be combining all of them together. Okay, so we can combine all of the runnable all together. It is also possible. Let me show you. So let's say this is the runnable lambda example. You can see, to use a custom function inside LCEL chain, we need to wrap this up with a runnable lambda. Let's define a very simple function to create a Russian last names. Okay, so what I'll show you guys, I'll show you one example. Let's say here I created one function called Russian last name. If you see any kinds of Russian last name, you will see this particular word called ovis. Okay, ovis, any kinds of name. Let's say you can give let's say Abram, you can give Bappy, you can give, let's say, any name. You will see that this would be the spelling at the last of that particular, let's say, name. Okay, that's why here we have created a function called Russian last name. This will take one input called name, and name should be integer, string, and it will also return as a string output. And here I'm returning, guys. Here I'm writing a if string. Inside that, whatever input user is giving, that is whatever name user is giving, I'm just adding with this obvious. Okay, that's it. So now let me execute. Now let me show you one example how this will work. So let's say this is my function. Inside that, if I give, let's say, Bappy, you'll see that with Bappy, actually it will add this particular word called obvious. Got it? Now let me delete it. It's not required. Now, in order to use this function inside my chain, okay, we'll be using runnable lambda. Now let me show you one example. So here is the example, guys. So you can see I'm importing this runnable lambda from the runnables, from the LangChain code. So the first runnable will be adding the runnable pass through. Why runnable pass through? Because I think you know this sequence of execution. Remember, guys, sequence of execution. Whenever we are creating any chain, C1, C2, okay, C3. So I have to go left to right, right? Left to right. So the first of all, what user will give? User will give the input data, yes or no. User will give the input data. This input data I have to receive. And how we can receive? With the help of runnable pass through. I think you saw one example here. So with the help of runnable pass through, we can take this input, and this input will give me the same output as it is. Okay. So that means whatever input user is giving, it will come here, then it will return. Okay. It will return to the runnable lambda. That means this will go there. That means left to right. Input will come here. It will return as it is. Okay. The output of the runnable pass through will be input of the runnable lambda. And what runnable lambda is doing? It is taking one function. Okay. It is taking one function called Russian last name. Okay. Now I think you remember, guys, lambda function. Do you remember the lambda function inside Python? So inside lambda function, I think we used to also do the same thing, yes or no? Or maybe you have learned about higher order function inside Python. If you haven't learned, so you can check it out my YouTube channel, guys. So there I already covered the Python programming. So here I already covered. Okay, what is a higher order function? What is lambda function? There I discussed each and everything. Okay, this is the similar kinds of concept. That means a function is taking another function as an input. Okay, this is called higher order function. Now this function is doing, it is just adding this particular obs at the last of the name. Okay, now let's say if I execute this chain and if I show you the output, so what will happen? So let's say I'll execute. Now if I just write, let's say chain dot invoke, and if I now let's say give Buppy here. Okay, if I give Buppy here, so I'll give my name, just a minute, Buppy. Now see what will happen. Now see if I execute, it will give me Buppy obs. Why? Because first of all, Buppy will go inside runnable pass through. Runnable pass through will return this Buppy as it is. Okay, as it is. And then it will come to the runnable lambda. Runnable lambda will take the Buppy and it will execute this particular function, the function you are giving as an input. So this will add this obs with my name. Okay, so this is what actually we are doing. Now you can see with the help of multiple runnables, we can create a chain. So this is the idea, guys, inside LangChain. LangChain is nothing but you are creating the chains. You are creating the sequence of execution, sequence of action. Okay, the action you want to perform with your data, with your large language model. Got it? So this is what actually chain. Now this is a simple chain we have created. Going forward, we'll be also creating complex chain. We'll be using retriever. There will be using vector database and all. Okay, with the help of that, we'll be creating the complete chain. That means the RAG chain and all. Everything will be creating. Got it? I hope it is clear, all of you. What is runnable pass through and what is runnable lambda? Got it? Now the next one we'll be learning about runnable parallel. So this is, guys, one of the very important runnable inside LCEL. That means without that, you won't be able to create any kinds of big application. Let's say whenever you want to create any kinds of bigger application, let's say you want to create a complete chat GPT kinds of, let's say, chatbot. It's a bigger application. So lots of people will come, they will give the different prompts. They may pass is short prompt, bigger prompt. Okay, anything they can pass. So now if I want to handle this kinds of, let's say, execution, that means whenever I'm talking about big application, that means your chain would be also big. So whenever you are creating the chain, let's say C1, C2, and C3 and so on, dot, right? Your chain should be also big. So let's say if I'm following the simpler approach, that means the sequence approach, that means left to right. First of all, this chain will execute, then this chain will execute, then this chain will execute, and so on, right? Now you can see it is taking time now. First of all, this will complete, then this will start. This will complete, then this will start. So it is time taking. So it will be taking time as per the user input, as per the chain, okay, chain size in the application. So what we can do, guys, we can utilize the multi-threading approach here. That means we'll be running everything in the parallel. Okay, let's see if we're having a very big chain, and and with the help of that, you are getting the big application. That time we can execute in parallel. So I think you know multi-threading, parallel computing, yes or no, right? So at the same time, we can execute multiple operation. This is called actually parallel. Okay. So in LangChain also it is provide actually runnable parallel. That means we'll be using runnable parallel for running task in parallel. And this is probably the most important and most useful runnable from LangChain you will be using going forward. Go ahead. Now, there are some way actually we can write this runnable parallel. First of all, I'll show you the easy one. Okay, easy one. So this is the example, guys. So this is one runnable parallel example. You can see I'm importing runnable parallel from the runnables inside LangChain code. Now here I'm defining one object called runnable parallel. Inside that I'm giving two tasks. You can see the operation A. Operation A, actually I'm taking the runnable pass through. And what is runnable pass through will do? I do remember. Here, runnable pass through. It will only return the same input the input actually will be giving. So we are already familiar with the runnable pass through. And the second operation we are performing runnable lambda. That means the same thing. And what runnable lambda will do, it will take another function and it will perform the job. Okay, that means higher order function. You can see. Okay, now you can see the both operation I'm passing inside runnable parallel. Okay, that means this two operation will execute at the same time. It's not like that. First of all, it will complete, then it will start. No, it will start at the same time. It will also start. Okay, that means you can let's say execute this particular application in a very short period of time with the help of parallel computing, with the help of parallel runnable parallel. Okay, this is the idea. Now let me execute and let me show you. So let's say here I will run this chain. Let's say chain.invoke. I'll give Bappy. Now see if I execute. So here you can see operation A Bappy is coming, operation B Bappy OVC is coming, because here you can see it is also executing this particular function. Okay, so this is called runnable parallel, and this is the most used runnable you will be using inside LCEL. Trust me. Clear, all of you? You can add as many as, let's say, runnable you can. It's not like that you are having some restriction. No, you can create your chain as complex as you can. Okay, it's up to you. Now let me show you another example. Let's say what I will do. Just a minute. So we'll be adding some more, let's say, runnable with our chain. So for this, I'm going to use my LLM. So first of all, I will import these two library, str output parser and chat prompt template. What is output parser? I think you already know. So here I already showed you the example in my previous session. Okay, output parser, it will give you the output as a raw text. That means the string. Okay, and chat prompt template. Why? Because I'm using the chat model. If I want to create the prompt template, I have to use the chat prompt template. That's it. Now here I'll initialize my prompt template as well as the output parser. You can see I'm initializing both. So this is my chat prompt template, and this is my template I created. Tell me a curious fact about this. Is the input user will give me. Okay, soccer player, and this is the output parser object. Now here I'm going to create another higher order function. That means the same Russian last name from dictionary. Okay, that means whatever name user is giving, it will add the OVCR, and it will add from the dictionary right now. Okay, we'll be giving the dictionary as an input. From the dictionary itself, it will take the name. This is the idea. Now we'll be building the runnables. See, that's how we can build the multiple runnables. So you can see runnable parallel. Now inside operation A, it will do the runnable pass through. That means whatever input you will be giving, the same input it will give you as an output. Now the second thing, soccer player, that means runnable lambda you are executing. That means the input you are giving. Let's say we have given Messi. Okay, so what it will return, guys? It will return Messi only, because you can see runnable pass through you are executing, and runnable pass through will return as it is. Then the second execution we are doing runnable lambda, and inside that we are executing this function, and this function will add the OVCR, right? That means if I'm giving Messi, so it will happen. It will return as a Messi OVC. Okay, Messi OVC. And the second last operation we are performing the runnable pass through again. That means whatever Messi OVC it is returning, same it will take the input and it will give you the output, because again you are running the runnable pass through. Okay, in case you can also take any other runnable. It's up to you. Now here, after creating this runnable parallel, we are passing this output to the prompt. Prompt will give to the model, and model will give to the output parser, and output parser will give me the answer. Okay, so this is called actually multiple chain. Okay, multi-chain we have created. Now inside that, let me give some example. Let's say this is the execution I'll be doing. Name one is equal to Jordan, and name is equal to Abram. Now you can see this particular function takes the name. Okay, name key only, but here I have given name one. So whenever this will go here, it will take only this particular name, because it is matching with this particular key. That means Abram will be taking. Okay, now let me show you. If I execute, so see, one curious about Roman Abramovic. See, it is giving the Abramovic because it is taking this name, not this name, because this key is not messing here. Okay, I hope it is clear. You can also delete this part, but I've given as a dictionary input. That's why I've kept actually multiple key value here. Okay, just to show you. Now you can see whatever, let's say name you are giving, it is returning here. This name is coming here and it is giving the Ovic. That means Abramovic. And this Abramovic is again coming here, runnable pass through. It is again returning the same thing. Now it is coming to the prompt. Okay, now what would be the prompt? Tell me about a curious fact about Abramovic. Okay, then this particular prompt you are passing to the LLM. LLM is taking the entire prompt and it is giving you the output, and you are applying the output parser on top of it. And output parser will give you the raw text. Okay, that means the string output. This is the idea of the runnable. That means our parallel runnable. Okay. Now let's see some advanced use of parallel runnable. So now we'll be using the vector DB technique. That means we'll be creating one RAG. Okay, with the help of RAG, actually we'll be learning this runnable parallel. So initially, I think you remembered we already created some RAG, right? And there I already used LCEL technique, and there I used the basic technique actually. Okay, I was not using any kinds of runnable pass through and all. So now I'll show you. Here is the example. See. So here you are already familiar with what is FIAS, what is str output parser, what is chat prompted, and what is runnable pass through and runnable parallel. And from OpenAI we are importing chat model and OpenAI embedding. Okay. As of now, let's try to consider this is my data. Okay, I'm not opening any kinds of data, txt file, pdf file. I'm not opening. I'm directly passing the data, and this data is, you can see, DS with Bapi focuses on content on data science, artificial intelligence, ML, DL, CV, NLP, Python programming, and so on. Okay. Now this text I want to convert to the numerical representation. For this, what we'll be using, guys? We'll be using embedding model. You can see I'm using OpenAI embedding model, and whatever embedding I'm generating, I'm storing in the FIAS vector database, and I'm creating the vector retriever. I think you know what is retriever. Okay, I already explained. And this is my prompt template. So answer the following. Answer the question based on the only following context. That means whatever retriever you are created, this is your context, and this context actually it will take, and whatever question user is asking, it will take and it will give you the answer. So here I'm creating the prompt template, initializing the chat model, and now this is my chain. Okay, this is my chain. Now you can see I'm using runnable parallel, and inside runnable parallel, first of all, I'm mentioning the context. That means the retriever. Then the second, I'm mentioning the question. That means whatever question user will give. That means first of all, it will initialize the retriever and then the question. Now you can see this execution will be happening. Now whenever you will be executing the code, it will be happening parallelly. That means at the same time, okay, at the same time, these two operation will run. Okay, and whenever at the same time two operation is running, that means you are getting quick response from your application, yes or no. Otherwise, what will happen? First of all, this will run, then this will run. Okay, and it is time taking. But if you are utilizing your parallel, okay, parallel, let's say computing and all, that time you will see quick response you will be getting. Okay, so that is why we'll be using runnable parallel. And to define runnable parallel, you can use this approach. Either you can use any other approach. I'll tell you what are the approaches are available. Okay, now after that we'll be giving the prompt. That means whatever output will be getting, let's say my input is what is DS with Bapi. So first of all, it will give the retriever to the context. Okay, you can see this is the context. That means the entire retriever will go to the context. And question, what is the question? This is the question user is giving. What is DS with Bapi? So this question will come here. You can see runnable with the help of runnable pass through, it will store here. And your prompt is also taking the question. After that, it will create the entire prompt. Entire prompt means answer the question based on only the following context you have given, as well as the question you have also given. Okay. Now this will give you the entire prompt. Now this prompt you will be passing to the LLM, that means model. Okay. Now model will apply this prompt and it will give you the response. And this response you are passing to the str output parser because it will give you the string as an output. Okay. Now this is my question, guys. What is DS with Bapi? And you can see this is a simple RAG we are implementing. Now see if I execute it, so it will be able to give me the answer about DS with Bapi because here I have given the information of my data. Now you can see DS with Bapi is a platform that focuses on providing content like data science, AI, ML, CV, NLP, Python programming, etc. in English language. Okay. Now see, amazingly it is running. And the execution you saw, okay, the execution you saw, it's like quite amazing because it is running in the parallel. Okay, it's a simple example, but going forward we'll be creating very complex application. There we'll see that inside parallel, okay, inside runnable parallel, you can add so many runnables, you can add so many executables, so many actions. Okay, it's up to you. Just to give you the understanding, I'm giving you let's say 3 to 4 examples, but whenever we'll be building the project, that time you'll see the complexity. Got it? Yeah. Fine. Now I think you I told you there is another things inside runnable parallel called IMGetter. Okay, now let me show you one example of IMGetter. Okay, so this is the example I already prepared. So you can see I'm importing this IMGetter from operator. Okay, operator is a library inside Python. So here I'm importing it. Then I'm importing fires, output parts such as complete, runnable, pass through, okay, OpenAI, and so on. That means whatever things we imported previously, the same thing we're importing. So creating the model, creating the vector store retriever template, and see inside template, the modification I did here, insert the following answer in the following language. So here user can also specify the language, like in which language you need the output. So here you can see this is the prompt, answer the question based on only the following context, and this is the question user is asking, and here user is specifying I need the answer in the following language. Now you can give any kinds of language, you can give Spanish, you can give pirates, okay, you can give any kinds of language. Okay, now see I'm creating the prompt template, and this is going to be my chain. Now see, now I'm executing this particular this one, your runnable parallel. Now you can ask me, sir, what is runnable parallel? Because previous example you showed me, this is the runnable parallel. I was using a function. Okay, I was using the function from the LangChain. Okay, yes or no? Runnable parallel, you can see we imported. But here we are not using this runnable function. Let's say, runnable parallel. Okay, we are not using runnable parallel, but you are telling this is a runnable parallel execution. Okay, why? Because inside LangChain, they will give you actually different kinds of way actually you can define this runnable. So let me show you. So here I have taken one screenshot. So this is the screenshot. Let me open up my Blackboard and let me show you here. See, there are some several way you can define this runnable parallel. So the first way you can define like that, we have already learned, right? Runnable parallel, inside that you can define the context retriever, question, pass through. Then the second way you can define that, you can instead of taking the string, you can directly give as a variable name. Okay, inside that you can pass. And this is the third way. Okay, now see here I'm not using this runnable parallel function. Okay, I'm not using it. Instead of that, I'm using this particular bracket. You can see I'm using this curly bracket. Okay, and whenever you can see this curly bracket, that means it is using the runnable parallel runnable parallel executor. Yes, that means whenever you can see this particular bracket, that means this curly bracket, you have to remember they are executing something called runnable parallel. So by default LangChain actually created this thing. So they are telling just instead of calling the function again, we can use this bracket. So for the fresher it would be a little bit confusing initially. But if you practice, if you just let's say implement the product regularly, definitely you will make a habit on this. Okay, so this is how actually you have to use this runnable parallel. Okay, so I showed you 3 different syntax, guys. Now you can use any of them, but this is the most used one. If you open up any kinds of documentation, if you open up any kinds of example of the LCEL, you'll see that people are using this particular approach. Okay, instead of using the functionality they are giving. Okay, now you can see inside that I'm having the IMGetter. Okay, now the example I showed you here, inside example, what is the changes I have done? The changes I have done, the answer actually I also want to specify the language. That means this particular application takes 3 input. The first input is the context, second input is the question, and the third input is the language. Okay, now you can see I'm taking the input one by one from the user. Okay, so the first thing will be taking the context. Okay, that means the retriever with the help of IMGetter. Now the second thing will be getting the context question. Okay, from the question, and the third one will be taking the language. Okay, with the help of IMGetter, you can see the language. Now after getting it, this is my parallel. Okay, this is my parallel actually runnable. That means all the 3 operation you have written, it will execute at the same time. Then it will pass it to the prompt. Prompt will create the entire prompt. Then it will pass to the LLM, and LLM will give me the response. And this response actually I'm converting to the string output. Okay, and here is the input operation we are doing. So this is my question and this is my language. That means I want this particular response to be in a pirate English format. Okay, now see, if I execute the program, you'll see that it will give me the answer in a pirate's English format. See, harem ds with Bappy is a scaling, but blah blah, you can read it out. Okay, so this is called actually pirate is English. So now you can give anything, Spanish, Hindi, anything you can give, it will give you the same output. Okay, now let's see, whenever you are having the multiple input, that time you can use this IM getter, okay, inside runnable parallel. Okay, so this kinds of functionality LangChain also will give you. Clear, guys, all of you? Let me know, because there are some super important runnable, okay, you'll be using inside LCEL. Nearby, I know since 2021 from the Indian, I also in the previous to interact with you at the Indian platform and you to know that you what you are doing from the community priceless. Many thanks. Yeah, thank you, Junaid. Sir, can I provide an video on level 3 application and deployment the cloud platform? So first of all, let's try to complete the basics, then we'll be also implementing the application, okay? Because there are so many things you have to learn if you want to reach to the level 3 application. Fine. So yes, so this is what actually our built-in runnables inside LangChain. That means our inside second generation LangChain. Now, if you see these kinds of syntax, guys, okay, if you see these kinds of syntax in the documentation, in any other implementation, now you will be able to understand, okay, what is happening exactly in that code. What is this syntax exactly? What is this syntax exactly? Okay. Now I think it is making sense, yes or no? And always try to remember, guys, whenever you see this curly bracket, you have to remember this is a parallel runnable. Okay, runnable parallel, sorry. Okay, it's a runnable parallel. Okay. Now in the next session, I'll be discussing about some more topic, like we'll be discussing about built-in function, next agenda, built-in function in runnable. Okay, runnables. The second thing we'll be discussing about combining chains, how to combine chain. And third thing we'll be discussing about we'll see one demo, okay, demo of LCEL, that means LangChain expression language, LCEL. Okay, that's it. So this is the next example. Okay, after that your this LCEL will part will be covered. Okay, now you can use this LCEL technique to implement any kinds of Gen AI based application. And no need to worry, I'll also show you some application. That application you can also build up. Got it? Yes. And this notebook would be given in the description. So in the description, you will see that I already added my GitHub link. From there, you can get all of the code. So let me commit here. So here I can write day 8 added. Okay, so now if I go to my GitHub, you'll see that this date is updated and this is the notebook. So let me share you the link. So this is the link. So please try to practice whatever things I showed you, because this is very important, guys. Trust me, this is very important and this is the basic. Okay, so if you have the doubt with respect to that, so definitely you will be getting let's say difficulty whenever you will be implementing the projects, okay, with the help of second generation LangChain. And let me know if you have any doubt. You can comment. You can also connect me on my LinkedIn. So here is the LinkedIn, guys. So this is my LinkedIn. Here also you can connect me. Fine, you can follow me, you can connect me. So now I think now I'm going to end the session, and please try to subscribe to the channel, try to support the channel, try to share, and always try to see the live section, because in the live section I always give the update. Okay, if anything live is coming and all, so everything would be available here. Fine. And apart from that, guys, I started another playlist called end-to-end deep learning project implementation. If you're interested learning deep learning implementation, you can also see that particular playlist. So yes, guys, this is all from today's session. Bye everyone, good night, and happy learning all of you. Thank you.